Okay, so today I want to talk about section 2.8, related rates. This is our line. I want to talk about what is a related rate problem. Second one, how can you solve a related rate problem? Last one, I will give more examples about a related rate problems. The first one, we consider pump air into a balloon. So what happens? Both the volume and the radius of the balloon are increasing. So what does it mean? The rates of increases are related to each other. So what does it mean? The increase of volume is depending on the increase of radius. The increase of radius is depending on the increase of volume. The two rates of increases are related to each other. We call the related rate problem. So how can you solve a related rate problem? We can follow these steps. Step 1, draw a diagram if possible and introduce notation. Step 2, express the given rates and the unknown rate in terms of derivatives. Step 3, write an equation that relates the various quantities of the problem. Step 4, use the chain rule to differentiate both sides of the equation with respect to time t. The last step, substitute the given information into the resulting equation and solve for the unknown rate. It's like a whole idea. I'm going to give examples here. The air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? So I'm going to follow these 5 steps. I will follow these 5 steps. Step 1, draw a diagram. What's like a diagram? The diagram is here. We have spherical balloon. You can draw just a spherical balloon. The spherical balloon is increasing. So that's it. This is like a diagram. It's like a diagram. So like this. Next is, what kind of a notation do we need here? We need volume. We need radius. We need time. Is right. So here, V is volume, R is radius, the T is time. The next is, need to find the given rate and the unknown rate. What's like a given rate? Given rate is here, given number. 100 cubic centimeters per second. What's that? Each volume increases at a rate of 100 cubic centimeters. What does it mean? We have the rate of increase of the volume of air with respect to time. I'm going to use notation. The dV over dt. What's it like a dV over dt? The rate of change of volume with respect to time t. It's like exact meaning. The dV over dt is 100. So we have it. What's it like unknown rate? Do you know what's like a notation of unknown rate? Could you write your answer? The next one. It's like a given rate. Do you know what is unknown rate? Do you know unknown rate? Could you write your answer on the chatting board, please? Okay. Okay. How about the other students? You have the same answers? Oh, yep. It's right. Here. From the question, how fast is the radius of balloon increasing? So like this. The rate of increases of radius with respect to time t when here. The diameter is 50 centimeters we don't have a notation of diameter, you can change it to radius. Radius r is half of diameter, 25 centimeters, like this. So we can use notation. What's that? dr over dt when r equals 25. This is unknown way. The next is, you need to find equation here. Find equation that relates volume and R. Do you know equation that relates volume and R? How can you find the volume of a sphere? Do you know that? What's the volume of a sphere? Do you know formula? So if you know the formula of a volume of a sphere, could you write the answer? Okay. Okay. So how about other students? So what do you think? What's it like a volume of sphere? So do you have any idea? Yeah, volume of sphere is the next one. So you need to memorize. The volume V is the 4 over 3 pi r cubed. The volume is 4 over 3 pi r cubed. This is exactly the equation that relates volume and the radius r. Step 4, differentiation. Like this one. You can take a derivative always with respect to time t, just like a key. Take a derivative with respect to time t. You can take a derivative. So what's that? Here, dv of dt is the 4 over 3 pi is coefficient, take out. 4 over 3 pi, the derivative of dt, r cubed. So do you know what is t r cube of dt? What's r cube prime? What's the derivative of r cube? So could you run your answer on the chatting board? What is t r cube of dt? The 3r squared, the 3r squared. It's right, 3r squared. So that's it. The 3r squared. So let me see. What is the variable? R is a variable or not? Which one is a variable? Here, t is a variable. So be careful. What is a variable? The t is a variable. What is r? The radius r is changing with respect to t. What does it mean? The radius is depending on time. Time is increasing automatically. Radius is increasing. R is function of t. So you can use chain rule. What does it mean? 4 over 3 pi. The r cube prime is, yes, 2r squared times inner function r prime, dr over dt. So like this. You have it, this kind of things. Really be careful. Next, the cross out 3, the 4 pi r squared, dr over dt. The next, the substitute and solve the equation for dr over dt. So from here, we have to solve this equation for dr over dt. What's that? dv over dt equals the 4 pi r squared dr over dt. So you have to substitute given information. Where do we have given information? The given information is always from step 2. We are going back to step 2. Here, what's that? The dv of dt is 100, r equals to 25. We can plug these numbers into our given information. The same to what? Plug 100 into dr over dt equals 4 pi. The radius is 25 squared dr over dt. So like this. Next, divide the both sides by the coefficient of dr over dt. The 4 pi times 25 squared here. 4 pi times 25 squared. So what happens? Whole thing is crossed out. Here, 4 and 25 crossed out, totally 100 crossed out. What's that? The remaining part is 1 over 25 pi equals dr over dt. So we have it like this one. So we need unit, the centimeters per second. What is the answer? The radius of balloon is increasing at the rate of 1 over 25 pi centimeters per second. But that's it. This is the whole idea for solving the related rate problem. I'll give more examples. The A letter, 10 feet long, the rest against the vertical wall. If the bottom of the letter slides away from the wall at a rate of 1 foot per second, how fast is the top of the letter sliding down the wall when the bottom of the letter is 6 feet from the wall? So, first one, you can draw diagram and notation. What's it like a diagram? The diagram is like this. We have vertical wall here, vertical wall and ground. One more, 10-foot long ladder is rest against the vertical wall here. So we have the like this. This is 10-foot ladder. The length of ladder is 10 foot. So next to what happens? This bottom of the ladder slides away. Top of the ladder sliding down, the change it. So which value change it? Here, the length between the bottom of the ladder and the wall is changed in the right axis. So this is sliding down. What does it mean? The length between top of the ladder and ground, y is decreasing. So we need these kind of notations. The t is exactly time. So we have it. So like this. That's right. So we need this notation and this diagram. The next, you can find the given rate, the unknown rate. Could you find the given rate from the example? What is the given rate? Do you know what is the given rate from the problem? Could you write your answer on the chatting board? What's the given rate? Is it 1? Is it right? 1? 1 foot per second. Yeah, 1. Yeah, here. You're right. 1. The 1 foot per second. What's that? The bottom of the ladder slides away from the wall. So here, this value changes. The derivative is like a rate of change of x with respect to time t. The rate of increase of x with respect to time t, we can use a notation. dx of dt equals 1 foot per second. What is unknown rate? The unknown rate is here. Question, how fast is the top of the ladder sliding down the wall? So what does it mean? Here, y value is decreasing. The rate of decrease of y with respect to time t, when the bottom of the ladder is 6 feet from the wall. So the rate of decrease of y with respect to time t when x equals 6. So we can use notation, the derivative of y with respect to time t when x equals 6. This is like unknown rate. The next, you need to find equation that relates x and y. Relates x and y. What's the equation? Do you know equation with x and y? You can use Pythagorean theorem, is right? Yes, this is like a right triangle. We can use Pythagorean theorem. X squared plus y squared equals 10 squared. So we can use this one. This equation, you're right. So we have x squared plus y squared equals 100. Step 4, differentiate. So take derivative always with respect to time t. time t. What is dx square of dt? What's that? Could you write your answer? What is dx square of dt? What is x square prime? Could you write your answer on the chatting board? 2x is right. 2x. That's it. You don't need more. Only 2x. The 2x dx of dt. The 2x times dx of dt is right. So what do you think? Yeah, 2x times dx of dt. Because what is the variable? The variable is always t. What is x? X is function of t. The function of t is right. The function of t. So you can try to solve the related rate problem. What's the variable? Variable is always t. What's x? X is function of t. The function of t. You can use chain rule. What's that? 2x times dx of dt. Always like this. Plus the y square prime is similar. 2y times dy over dt. The 100 prime is only 0. So we have it. It's like idea. It's good. So really be careful. The variable is always t. T. We can use given information. What's given information? Given information is here. The dx of dt is 1. The x equals 6. So what's that? From here, the x equals 6. dx of dt equals 1. But we have one trouble. How can you find y? So do you know? How can you find y? So do you know? How can you find y? Do you know? How can you find y? Same. We can use given information here. What is x? X equals, yes, Pythagorean theorem. X equals 6. Find y value by using Pythagorean theorem. This is the idea here. So we have it. So you can find here. Pythagorean theorem. X equals 6. Find the y. What's that? The 6 square plus y square equals 10 square. So we have the 36 plus y square equals 100. Subtract 36. The y square equals 64. The y is positive 6, 1, negative 6. The y is only length. We don't deal with the negative y equals 6. Sorry, 8. Sorry, 8. You can erase negative 8. The y equals 8. So this is the idea. Y equals 8. So one more. So how can you find this value y? The Pythagorean theorem is one good idea. Another one, we can use special ratio of a triangle. Do you know this kind of special ratio of a triangle? You know that? The 3, 4, 5. This is one special thing. Do you know what's that? This is exactly the 2 times 5. The 6 is 2 times 3. We have 3, 4, 5. Automatically 2 times 4. We can use 3, 4, 5. Y equals A. The either one is fine. So you can use like a special ratio or this one. So do you know this one? Another special ratio. What's that? What's hypotenuse? 5, 12. Do you know this one? Yes, 13. This is another special ratio. 5, 12, 13. The 3, 4, 5. So these special ratios are very useful. Very useful. So anyway, you can use a Pythagorean theorem. Next, you can plug here. From the previous one, what is x? X is 6. Dx of dt is 1. The y is 8. So we have the 6 times 1 plus 8 times ty over dt equal to 0. You can subtract 6 from both sides. 6 is cancelled. 8 times ty over dt equals negative 6. The last one, divide the both sides by 8. 8 is cancelled. The ty over dt is negative 3 over 4. So one more. Why do we have a negative number? Do you know the reason? Why do you have a negative number? Do you know what is the reason? Why do you have a negative? What's that? Why? Yes, sliding down. This is the reason. The x is sliding away. The dx of dt is positive. The what is like the top of the letter sliding down. Y value is decreasing. This is the reason. You can going back to previous one here. So this is the reason. Decrease. The rate of decrease of y always negative number. Like this. We have negative 304 foot per second. That's it. This is the whole idea for solving this problem. The next example, the very similar one. A ladder 10 foot long rests against the vertical wall, the similar. The bottom of the ladder slides away from the wall at a rate of 1 foot per second, same. The question is different. How fast is the angle between the ladder and the ground changing when the bottom of the ladder is 6 feet from the wall? So what kind of things do you need? We use the same diagram. The first one, the diagram is the vertical wall and ground, the ladder is the same, 10 foot. One more. Bottom of the ladder slides away here. Bottom water slides away, we need x. So one more. How fast is the angle between ladder and the ground? We need angle theta. You don't need y value, like this one, 10x theta. That's right, so like this. So x is same. The distance from the bottom of the ladder to the wall. The angle between the ladder and the ground theta, the t is time. Step 2. So same, given rate, unknown rate. What's like given rate? The rate of increase of x with respect to time t, the same. The dx of dt is 1 foot per second, the same to the previous example. What is unknown rate? Unknown rate is the rate of change of angle. The rate of change of angle with respect to t when x equals 6 feet. You can derive t theta of dt at x equals 6. This is the idea. The next thing, you need to find equations, right? Equation that relates x and theta. So going back, what's the equation? Do you know equation? What's the equation? What's the equation with angle theta and length x? Do you know that? Which one is better? Yes, we have to use the cosine function in this case, depending on. So do you know, like what's the definition of cosine, sine, tangent? You need to know these kind of things better. So we have one triangle is given, like this, angle theta. We have x, y, z are given. What's it like a sine theta? The sine theta is like opposite over hypotenuse, the y over z. What's a cosine theta? The cosine theta is the adjacent over hypotenuse, x over z. What's it like a tangent theta? The tangent theta is the opposite over adjacent, y over x. So you can decide, so which one do we have? In this problem, we have tan and x. X is adjacent, tan is a hypotenuse. We can use cosine function. So we have cosine theta equals the adjacent over hypotenuse. So that's it. This is the idea. You're right. So we have it like this. The next differentiate. You can take a derivative the both sides with respect to time t. So what is first one? What's that? Do you know this one? Could you write new answer on the chatting board? What is your answer? What's that? The negative sign. That's it. You're right. Here, negative sine theta. The one more. That's it. Do you do more or not? Here, what's the variable? T is variable. What's theta? The theta is function of t. Always, yes. d theta of dt. You can write this. Equals, what is second one? What's that? What's the right hand side? d over dt, x over 10. What is the answer? Do you know this one? What's that? The 1 over 10 is right. The 1 over 10. The 1 over 10 is right. 1 over 10. So let me see. What is a variable? Yes. 1 over 10 times dx over t is same. The 10 is like constant takeout. d over dt x. What's a variable? T is a variable. What's x? X is function of t. Really be careful. Function is not a variable. The function of t exactly 1 over 10 times just dx over dt. So like this. We have it. Step 5 is substitute. Why like substitution? Here. You can substitute the dx over dt equals 1, the x equals 6. X equals 6. So here, the dx over dt equals 1. How can you find sine theta? You can use the remaining information, x equals 6. So you can plug x equals 6 into here. Plug 6 into here, find y. Same to the previous example. This is like 8, we have it. So this is angle theta. What is sine theta? Sine theta is opposite over hypotenuse. So we have negative 8 over 10 times d theta over dt equals 1 over 10 times dx over dt is 1. The dx over dt is 1. Times 1. You can multiply the both sides by the reciprocal of d theta over dt. The multiply the 10 over negative 8. The 10 over negative 8. Negative 8. 10 is crossed out. 8 is crossed out. Change positive. Only d theta over dt is 10 is crossed out. We have negative 1 over 8. What is unit? Do you know what is a unit? What's like unit of angle? What's unit of angle? So what's that? You can use degree or radian. Which one? Degree or radian. So what kind of things do you use? Degree or radian. Yeah, you always use radian. In this problem, we don't have any notation of degree, just use number. The number is radian. We have radian per second. It's like answer. The radian per second. That's it. This is the whole idea for solving this problem. Okay, the next one. Here, the water tank has the shape of an inverted circular cone. So we have the inverted circular cone with the base radius 2, the height is 4. if water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. So you need inverted circular cone. So here, inverted circular cone. So like this, inverted circular cone. What is it? Height 4 meters. The radius is 2 meters. So like this. So one more, water is being pumped into the tank. What's that? The water is, like this is water, is like increasing. You need the radius R, the water level height is like H. You need these kind of things. It's like an exact diagram, like this. So you need the volume V because we have the notation of volume. So we need height, the R, radius of surface, T is like time, right? The radius of surface and time T. The next one, was it given rate, was unknown rate? The given rate is here, the 2 cubic meters per minute. The unit of cubic meter is exactly volume, is right? This is like a volume. So what does it mean? The increase of volume, the change of volume with respect to time t, we can use dV of dt equals 2 cubic meters per minute, right? 2 cubic meters per minute. Next, unknown rate is the rate of change of water level, the dH of dt. When the water level is 3 meters. So dH of dt when h equals to 3, just like given rate. Next, you can find equation that relates V and H. How can you find this one, V and H? What's like a volume of a cone? Do you know volume of a cone? Do you know volume of a cone? Only this portion, the water part, only volume of cone, only water part. So what's that? Volume V is, remember, what's the volume of a cone? The volume of a cone is, you can memorize, the 1/3 pi r square times height. This is like volume of a cone, the volume of a cone. The one more, just like equation, the what kind of ratio do we have? Only V and H. We have what? Only V and H. We don't have R. So what does it mean? You can change R to function of H. You can change R to function of H. How can you change R to function of H? You can use this one, similar triangle. Do you know this one? Bigger one? This bigger triangle is, you can draw here exactly. Bigger one is 2 and 4. And small one. This small one is, you can draw here. Small one is like this, similar. So we have same angle and same angle. So similar. So this one is R and H. So like this. You can use proportion. What's that? 2 over R. So we have 2 over R equals the 4 over H. You can use proportion of a similar triangle. The same to the 4 times R equals 2H. Just a cross product. Divided by 4. The R equals 2H over 4. 2 is crossed out. H of 2. You can plug this value into here R. So what's that? The volume V equals 1/3 pi times H of 2 square times H. We have 1/3 pi times H square over 4 times H. So we have the pi over 3 times 4 is 12. H squared times H is H cubed. So that's it. We have this one equation. The volume is pi of 12 H cubed. We have one equation. So like this. So we have it here. This is my explanation, the same. You can plug, we have the like this. Was it like step 4? Differentiation. You can take derivative. So take derivative with respect to time t. The first one, dv of dt, same. The pi of 12 is like a coefficient, only take out. So we have equals pi of 12 d over dt h cubed. So my question, what is dh cubed of dt? Could you write your answer? What is dh cubed of dt? So what is your answer? What is dh cubed over dt? So could you write your answer on the chatting board? Yes, same. What is t? T is variable. The h is function of t. You always use chain rule. So we have pi over 12 times the 3 times h squared times dh over dt. You can use chain rule. The 3 is crossed out, change 4. So we have this result. The dv over dt equals pi over 4 h squared dh over dt. So we have it. The next step here, so we have it like this. The next step is substitute and solve the equation for dh over dt. How can you substitute? You have to use previous given information in step 2 here. What's like step 2? Step 2, the dv of dt is 2. The h is 3. You can use these 2 information. You can plug into the here. What's like dv of dt? The dv of dt is 3. No, 2. Sorry. The dv of dt is only 2. You can plug 2 into here. Plug 2. The what's like h? The h is 3. You can plug 3. So we have 2 equals pi times 3 square over 4 times dh of dt. So like this. And simplify the pi times 9 over 4 dh over dt. Is right? So we have like this. The next tip, you can multiply the both sides by the reciprocal of 9 pi over 4, the 4 over 9 pi times 4 over 9 pi. What's that? 9 pi is crossed out, 4 is crossed out. The right hand side has dh over dt equals, so this is 8 over 9 pi. So that's it. This is the idea. So we have 8 over 9 pi meters per minute. The meter per minute. So we have this answer. The water level is rising at a rate of 8 of 9 pi minute per, sorry, the meter per minute. The next example, the car A is traveling west at 15 miles per hour. Car B is traveling north at 16 miles per hour. The both are headed for the intersection of 2 roads. At what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile from the intersection, right? So what's that? So we have draw diagram. What's like a diagram here? Intersection of 2 roads. We have intersection of 2 roads. So you can draw like this one. The car A traveling west. The car A is here, traveling west. Car B is traveling north. The car B is traveling north. So like this. So what happens? The speed of car A is given. What does it mean? The x variable, the distance of time, we need distance x. The speed of car, the A and the B is also given. This is like y. Was like question. At one rate, are the cars approaching each other? What does it mean? You need to find distance between two cars like z. So this is like a diagram. So we have it. X is distance from A to C, intersection point C. The distance from B to C, Y. The distance from A to B is like Z. So we need this kind of notation. The time T. Time is like T. So we have it. The next T. Need to find the given rate and unknown rate. How many given rates do we have in this problem? How many given rates? So do you know what's the given rate? Yes, we have 60 miles per hour to 50 miles per hour. So here, the rate of decrease of x with respect to t is right. So tx of dt, what's that? Car A approaching C, what happens? Distance x is decreasing, always use negative 50 miles per hour, so like this. So one more, the rate of decrease of y, this is the speed of car B, is 60 miles per hour, the same. The B is going to C, the what happens, length y is decreasing, the dy of dt is negative 60 miles per hour. The next tip, you need to find the unknown rate. Unknown rate is the rate of decrease of, here, decrease of distance between two cars. So when car A is 0.3 mile, car B is 0.4 mile. So we have the rate of decrease of z with respect to time t when x equals 0.3 mile and y equals 0.4 mile. So we have this one. The dz of dt at x equals 0.3, y equals 0.4. It's like unknown. The next to find the equation that relates x, y, and z. Going back. So from this diagram, you need to find equation with x, y, z. What's the equation? You know what is the equation? So could you write your equation on the chatting board, please? What's the equation with x, y, z? What's the equation? The equation with the x, y, and z. What's the equation? Could you write your answer on the chatting board, please? Yeah, you're right. So you can use Pythagorean theorem, is it right? The Pythagorean theorem? Yes, it's like exactly right angle. You have x squared plus y squared equals z squared. Yes, we can use Pythagorean theorem. So like this. Next, differentiate. So next one. What is dg squared of dt? What's that? What is dg squared of dt? So could you write your answer on the chatting board, please? What's that? The 2z. The 2z times dg of dt. 2z. The same. So really be careful. What is it like variable? T is variable. What is it like z? The function of t. Always 2z times dg of dt. So really be careful. So like this. What is dx squared of dt? So what's that? Could you write your answer on the chatting board? What is dx squared of dt? So could you write your answer on the chatting board? Okay. How about the other students? So you have the same answer? Could you write your answer? Okay, good. So we have 2x times dx over dt plus similar y square prime the 2y times dy over dt. It's like whole idea. So we have this equation like this. The next thing, substitute and solve this equation for the unknown rate dg of dt. Much like a given information, we have given information is here. The dx of dt is negative 50. The dy of dt is negative 60. X equals 0.3, y equals 0.4 here. So what's that? X equals 0.3. The y equals 0.4. The dx of dt equals negative 60, right? The negative 50, sorry, negative 50. The dy of dt equals negative 60. So you need z. How can you find z? So do you have any idea for finding z? Do you know? How can you find z? The 3, 4, 5 triangle and the fastest one? Yes, we can use triangle. We are going back to here. Triangle. What's like y? The y is 0.4. X is 0.3. You can use the special ratio 3, 4, 5. 3, 4, 5. The 0.3, 0.4, 0.5. The g equals to 0.5. This is like idea by using right triangle. So here, this is 0.5. And solve dg of dt. This is the whole idea, like this. The Pythagorean theorem, do we have it? Next, you can plug, that's right? The 2 times 0.5, dg of dt equals 2 times 0.3 negative 50, 2 times 0.4 minus negative 60. The 2 times 0.5 is 1. The 2 times 0.3 is just 0.6. 0.6 times negative 50 is negative 30. The 2 times 0.4 is 0.8. 0.8 times negative 60 is like a 48. So we have negative 30 minus 48 is negative 78 miles per hour. It's like a whole idea for solving this problem. So the cars are approaching each other at a rate of 78 miles per hour. It's like a whole idea for solving this problem. The next example. The one man that walks along a straight path at a speed of 4 feet per second. A such light is located on the ground 20 feet from the path and is kept focused on the man at one rate is a such light rotating when the man is 15 feet from the point on the path closest to the such light. It's like a question. So let me see. What's like a diagram? The diagram is next one. We have straight path. The one man standing on straight path here. And such light is located on the ground 20 feet from the path here. This is such light. So this distance is like 20 feet. 20 feet. The next, this man moving to the right hand side or left hand side. Which one? Could you decide which one? This man move to the right or move to the left? Which one? Could you write your answer on the chatting board, please? Which one? To the right. Yeah, to the right. One student should say right. How about other guys? So could you choose only 50% correct answer? Okay, right. So you don't have any answer of lefty? No, only right? So east is right, I think. Yeah. So another answer is good. So let me see. In this problem, do we have a direction of this man in this example? We don't have it. So we don't have any direction. What does it mean? Either one is fine. So this man is moving to the right, moving to the left. It doesn't matter. It doesn't matter. Either one is fine. We have the same answer. So in this case, I just only use right hand side. You can choose either one. It doesn't matter. I can choose here. So move to the right. So here, what happens? So this searchlight only focus on this guy. So this angle change it. So length change it. We need this kind of a diagram like this. So here, the distance from the man to the point on the path closest to the searchlight is x. The angle between the beam of the searchlight and the perpendicular to the path is like theta. T is time. So you can find the given rate, the unknown rate. What is the given rate? The given rate is here. This man walks along a straight path at a speed of 4 feet per second. We need rate of change of x with respect to time t. We have dx of dt equals 4 feet per second. This is positive because length x is increasing. The unknown is here. So at one rate is a searchlight rotating. What does it mean? The rate of change of angle theta with respect to time t when x equals 15 feet, the d theta of dt at x equals 15. It's like unknown rate. So next, you need to find equation that relates x and theta. So from the diagram, what is the equation? What's the equation with x and theta? What's the equation? So this one is like we have angle problem. What's the best way? You can choose sine, cosine, or tangent. Which one? Sine, cosine, tangent. Which one? The tangent? How about other students? So could you write your answer on the chatting board? The tangent, the same things? Is it tangent? Is right? Yes, this is tangent because here opposite and adjacent are given. Always use tangent theta. The tangent theta equals opposite x over adjacent 20. X over 20. We can use it. This is the equation. Next is differentiate. You can take the derivative, the both sides with respect to time t. So here, what is this one? What's that? What is d tangent theta over dt? So what's the answer? Could you run your answer? Was it like a d tangent theta over dt? What's that? The tangent prime is secant square theta. That's it. Times what? Same. The t's variable theta is function of t. Always use, yes, chain rule. The chain rule. This is like a key. Yep. Equals here. 20 is coefficient, take out only 1 over 20 dx over dt. So like this. The next thing here. Substitute and solve this equation for d theta of dt. So if you solve this equation for d theta of dt, you can plug given information. Was it like dx over dt? Was it secant square over theta? So from the previous step to the dx over dt are given. Here, the x is given. It's right. X is given. So what does it mean? So here. Substitute. So dx of dt is given. So dx of dt is exactly 4. This is 4. How can you find secant square of theta? We can use x value. What's x? X is 15. So from here, there's like a searchlight here. This is like a straight path. This distance is 20. So this value is man is stand here. So this is like a 15. So you can find this length, right? This length, this angle is theta. So what's that? You can use Pythagorean theorem or the special ratio 3, 4, 5. Which one? You can use 3, 4, 5. You can use 3, 4, 5. What's 15? The 15 is 5 times 3. The 20 is 5 times 4. What's hypotenuse? 5 times 5. Exactly 3, 4, 5. 3, 4, 5. We have 25. Was it like secant theta? The secant theta is same to 1 over cosine theta. Was it 1 over cosine theta? 1 over. Cosine theta is exactly adjacent over hypotenuse. We have 20 over 25. The reciprocal is 25 over 20. The 5 is crossed out. We have a 5 over 4. You can plug 5 over 4 into secant. So what's that? 5 over 4 squared. This one times d theta over dt equals 1 over 20 times dx of dt is 4. Or like this. So what's that? The 25 over 16 d theta over dt equals 4 is crossed out. Just 1 over 5. The next 25 over 16, the d theta over dt equals 1 over 5. You can multiply the both sides by the reciprocal of 25 over 16, 16 over 25. The 16 over 25. The 16 is crossed out. 25 is crossed out. Was it like d theta over dt? D theta over dt is 16 over 125. Was it like unit of angle? Always use radian. Was it like a time? The seconds. From the example. So this is like a whole idea for solving this example. Okay, so this is like I think the all lecture. So if you have any trouble, any question, could you write your question on the chatting board? I can help you. So if you don't have it, the more question, you can leave live session. So thank you for attending my live session. I appreciate. So the next time you can attend again. This is very helpful for me. So really thank you. You're welcome. So just write your question on the chatting board if you have any question. So I just waiting for your question. You too. You have a good night. Yeah. Thank you. Thank you. You're welcome. Okay, you're welcome. You're welcome. Okay, you're welcome.